Now, in this video, I want us to understand what is logarithm. I want us to completely understand everything concerning logarithm. Now, what do we mean by logarithm? Let us start with that. The logarithm of a positive number. That number, say it is n. Yeah. To base a, for example, is defined, we can define it, is defined as the power. So it is defined as the power, to which a must be raised. Nti power ki gye raising to a to obtain n. For example, if we write and say a to power x equal to n, this means that x is known as the power. Another name given is logarithm, and a is considered to be the base, and also n is called the number, or sometimes called argument. Now, to write it in logarithmic form, for this we come and say log base a of n is actually x. So this is how we write it in logarithm form. So in simple terms, logarithm simply means power to which a number is raised to which the base, is raised to obtain a number. Kati bw'omala otegeera ekyo, we have what we call laws that govern logarithms, and some of them that we commonly use. So laws of logarithms. So we have the first one that says if you have log base a of m plus log base a of n is actually log base a of m n. Now in this video we are going to prove each and every law, and we know where do they come from. So law number 2 tells us that if you have log base a of m minus log base a of n is actually equal to log base a of m out of n. That is law number 2. Law number 3 talks about if you have x log base a of m is actually equal to log base a of m to power x. So the power goes back. Now the fourth one says that if you have log base a of 1 is equivalent to 0. Another one, the fifth one, that the tutunuulira is log base a of a is actually 1. And also the sixth that we have is if you have a to power log base a of m is actually m. So when the bases are the same, the argument is what we obtained. So these are the laws of logarithms that are common, and we are going to prove each and every logarithm such that you understand. If you are still with me up to this level and you are still understanding, don't forget to subscribe and like this video, share it with your friend, and we enjoy it together. Let us move on to proving each law. Now we want to start with the first logarithm law that says if you have log base a of m plus log base of n is equal to log base a mn. Now I want to first prove this. So we want to first prove this. Now, how do we prove this? We begin by saying that let we let this log base of m to be something, and also log base of n to be something. So we let, for example, x equal to log base a of m, and also we come and say let y equal to log base a of n. Now we go ahead to write it in index form. In this form, this a is considered to be the base, and then m is the argument, and the x is the power. So we come and say a to the power x is equal to m, because we know very well that logarithm simply means power also. So we also write this as a to power y is equal to n. Now we can go ahead to multiply these two together. Now when we multiply these two together, we shall have a to power x times a to power y is equal to m times n. Now whenever we multiply the same bases, we know that we add the powers. So we have a to power x plus y is equal to mn. Now if that is true, since the base we are dealing with is a, so we apply log base a on both sides. So we come and say applying log base a on both sides. When you apply it on both sides, we shall have log base a to power x plus y, and then is equal to log base a mn. Now if that is achieved, we go ahead to come and say that this power drops here, so we shall have x plus y into log base a of a is equivalent to log base a m of n. Now we know very well that log base of a is 1, so we come and say but log base a of a is 1, so we remain with x plus y is equal to log base a mn. Now our x is this, we have x here, our y is this, so we come and say therefore log base a of m plus log base a of n is actually equal to log base a of mn. So hence proved. So this is how we prove the first law. We meet in the next law. Thank you. Now to prove the second law, this is the second law. To prove our second law, we also come and say the law says that if you have log base a of m minus log base of n is equal to log base a of m out of n. So we divide the arguments. Yeah. So if you are enjoying the video, don't forget to like, subscribe, and share with your friends such that you can learn together. So you also begin by saying let x to equal to log base a of m and y equal to log base a of n. So we have that. So we go ahead to write it in index form. In this form, we saw it in the first law that this is our base, this is the power, and this is the argument. So we come and say a to power x is actually m, and also a to power y is actually n. So now if you look at this, if we divide a power x out of a power y, So dividing, so you come and say by dividing, so you can have a to power x out of a to power y is actually equal to m out of n. Now, we know very well that division of the same bases, we subtract the powers. So, this can be written as a to power x minus y is actually m out of n. Now, after realizing that, we go ahead to say applying. So, applying log base a on both sides, we shall have log base a of a to power x minus y is equal to log base a of m out of n. So we divide. So now this one drops. So we have x minus y into log base a of a is actually equal to log base a m out of n. But we know very well that log base a of a is actually 1. So after knowing that fact, we go ahead to say that therefore we shall have x minus y equaling to, because this is 1, so 1 times everything will remain with that, will equal to log base a of m out of n. And what is our x? Our x is this. What is our y? Is that. So therefore, log base a of m minus log base a of n is actually log base a of m out of n. Hence proved. So that is our second law. Don't forget to subscribe, share with your friend if you have learned something. Thank you. We meet in the third law. In this video, we are going to prove two laws, the third and the fourth. Now, the third says that if you have x log base a of m is the same as x going back to being log base a m to power x. And also the fourth one is log base a of 1 is equal to 0. So let us begin with the third one. We come and say that let, for example, n equal to log base a of m. Now, writing this in index form, we know very well that we shall have a to power n is the same as m. Now, using the law of indices that tells us that, so using the law of indices that tell us that if I have a to power x and then I power it, y is the same as a to power x y. So using that law, I'm going to do the same here. I will say a to power n and then to power, for example, x is the same as, I also power it on the other side. So I do it on both sides. So when I do it on both sides, I will have now a to power nx is equal to m to power x. Now applying log, so if you're applying log base a on both sides, I'll have log base a to power nx is equal to log base a m to power x. So in this drops, I'll have nx log base a of a is equal to log base a m to power x. Now, this one we know it as 1. and also n is known as log base a of m. Therefore, our x log base a of m is actually log base a m to power x, hence proved. So that is law number 3. Now when you go to law number 4, we come and say from a to power 0 equaling to 1, that is a law of indices. Now to prove that any logarithm of any base of 1 is equal to 0, so we come and use the indices law that says any number to power 0 is equal to 1. So we come and say applying log base a on both sides, we shall have log base a of a to power 0 is equal to log base a of 1. Now the 0 drops, so we have 0 times log base a of a is equal to log base a of 1. But remember, anything to times 0, we get 0. So we have 0 is equal to log base a of 1. And then this is eventually where we have the law that says log base a of 1 is actually 0. So hence proved. So those are the laws of logarithms. If you have enjoyed the video, please subscribe. If you are new to this channel, share it with your friend and like the video. We meet in the next solving equations involving logarithms. Thank you.